Hey Calc students, this video is for 3.8 to go over implicit differentiation. We're going to go ahead, jump in and get started right away. So the first thing is kind of look at what's the difference between explicit versus implicit. Essentially, all the derivatives we've taken at this point have been explicit. And generally, we just want to think about that is that y is isolated. So we have an expression or an equation where the y term can be isolated. With implicit form, y is not going to be isolated. So y is not isolated. And that's what we're going to focus on today, is taking the derivative of equations in which the y value is not isolated. Now, there's some notation things to be aware of. So we have that notation dy dx, which means take the derivative of the function y with respect to x. And as we go through this, there's going to be some basic guidelines to follow. So when we are trying to take the derivative implicitly, the first step is to differentiate both sides of the equation with respect to x. And we'll talk about what that means. We're going to collect all terms involving dy dx on one side. And we're going to move all other terms to the other side of the equation. We can then factor out the dy dx from all those terms containing it and solve for dy dx. And that's how we will end up with our derivative dy dx. So we're going to jump into the examples. The first example here says to find dy dx using implicit differentiation. And our function is 3x squared plus y squared equals 2. Now, usually we're going to use implicit differentiation when it's challenging to isolate y. In this case, if we wanted to get y by itself, we would actually have to, subtract the 3x squared over, square root both sides, but that's going to give us plus or minus the square root of 2 minus 3x squared. So we have a positive square root function to take the derivative and a negative. Implicit differentiation is going to allow us to avoid that. So what we want to do is start taking the derivative just like we would in any other problem. So when we have 3x squared and we want to take the derivative, we can apply the power rule. So we're going to multiply by 2. 2 times 3 is 6, okay, x, and then the 2 becomes 1. And when the variable is x, you don't do anything different. Where it's going to be different is now when we take the derivative of y squared. Okay, y squared, remember, we're taking the derivative with respect to x. So what we have to do in this case, and this is where the implicit part comes in, is we're going to apply the power rule, so we get 2y. But then we have to multiply that by dy dx, the derivative of y with respect to x, and then that equals the derivative of 2, which is 0. So anytime you take the derivative implicitly, if the variable is not x, or what you're taking the derivative with respect to, you have to include that dy dx. Now, technically, you could think of there being, when you take the derivative of 3x squared, of getting 6x dx dx, so the derivative of x with respect to x, but that's always 1, which is why it's not necessary and we don't need it. All right. At that point, we are going to isolate the terms that have dy dx. So we have 2y dy dx equals negative 6x. We are going to then divide everything by 2y. We've now isolated dy dx. All we can do on the right-hand side is reduce. So we have a negative divided by a positive, so we're going to get a negative. So that's going to be negative 3x over y. And that is the derivative of y with respect to x for that function. So the key is when you're taking the derivatives, if we're taking it with respect to x, any time we take the derivative of a term that has a variable that is not x, okay, such as y, we're going to include dy dx. If the variable was, u, we could say du dx as we do that. All right, another example, a little more complicated, number 2. So this time we have xy minus 5x equals negative 14y squared. Now this would be a situation where even if we wanted to, we really can't get y by itself. So that implicit piece is necessary. What we want to recognize first is that xy is a product. So when we take the derivative of xy, we have to apply the product rule. So the first thing I'm going to do is take the derivative of x, which is 1, times y, plus. I'm going to take the derivative of y, which is 1 dy dx, and then times x. So times x. That is going to be the derivative of xy. And then minus 5, because the derivative of x is 1, equals, so on this side we're going to apply the power rule. We've got negative 14 times 2, which is negative 28y, but we have to include dy dx. So if we kind of rewrite this a little bit just to make it more simple, we have y plus x dy dx minus 5 equals negative 28y dy dx. So what we're going to do at this point is we're going to move all the terms with dy dx to the left and everything else to the right. So we're going to get x dy dx plus 28y dy dx equals. We're going to subtract y and add 5, so we could say 5 minus y. All right, the next step was to factor out the dy dx. So probably should have kept that color coded. So what we're going to do is we're going to factor out the dy dx from the left side. So we got dy dx, and it's just like taking out a greatest common factor. X plus 28y equals 5 minus y. And then all we're going to do is divide both sides by x plus 28y. So dy dx is 5 minus y over x plus 28y. All right, I'm going to end the first video here. Guys, there will be some additional videos to follow to go over this and just looking at more examples.